Hey, all right. It's Tuesday for me, but it's gonna be Wednesday or even Tuesday night when you see this. But hi, I miss all of you so much. Stay tuned in the coming weeks. I'm just gonna say that. Stay tuned. Okay. So today is your video for Wednesday. It's the last day that I'm going to make a video about just strictly vertex form and transformations. I actually changed my mind about the problems I'm going to do. I actually found a worksheet. Actually, I found a worksheet that has you guys converting from graph to vertex form and then from vertex form to graph like the packet. So maybe I'll do a couple of those, but I want to focus on the ones where you're given a graph and then you need to write the equation in vertex form. So just real quick, and then maybe I'll take a look at some Math Excel problems and see what you can do. And who knows, maybe I'll take a look at the textbook problems. For fun, I'm getting the textbook right now. So hang on to your seats. Hold on to your hats. Okay, so looking forward, remember I think I told some of you guys, most of you, well, I posted it, that you need to be updating your grades, making sure you're reaching out. And a couple of you have. Marvin, you're doing an excellent job. Javon, great job. Bruce, great job. Courtney, I spoke to today. Mikhail, you guys are doing a great job. Trying to get it together. I know that this was a rough start and this is very new for everyone and we're not fond of it. So listen, I understand. All you have to do is reach out to me. I'm not going to hold your hand. However, I will point you in the right direction, let you know what needs to be done when. Marvin, again, is doing a really great job coming to office hours and doing the work with me and asking me for help when he needs it. So if any of you out there are in need of that, please do so. I am here. All right? So let's get started on this worksheet I found. If you want me to, I'll post. Actually, I don't even know how you would tell me you want me to, but if you want, I'll post the link as an attachment on Enmodo if you wanted this. So write the quadratic function or equation in vertex form for each graph. So in number 1, they kind of give you what this is and how do we tell how do we get this into this equation. So the first thing you want to do is always find/locate your vertex. That's what you want to do first all the time. So in here, my vertex is 2, 0. So this is what this equation looks like. Now, you do not have to write the plus 0, so I would be okay with y equals, I would prefer y equals x minus 2 squared, okay? That's fine. Now, how did you know that we did not have an a? Well, you didn't. So we're going to go over here and we're going to see how that works. So find, locate your vertex. So for number 2, my vertex is at the origin, 0, 0. But I want to see, because I'm suspecting that this is going to be a vertical stretch. So I have a vertex and I want to actually locate you can't see, maybe you can, one additional point from the graph. Okay, so step 1 is my vertex. Step 2, let's look for one additional point. So if I'm not too blind, I think that an additional point is 1, 2. Does that look good? I think that looks pretty good. So if I'm locating 1, 2, and I have a vertex, that means I have 2 points. Now, I'm going to write down what I think my equation is. Well, vertex obviously is here. I know this is going to be x squared. So there's no horizontal, there's no vertical movement, so I can't do a parentheses minus, parentheses plus, k. There's no h and there's no k. So what I'm trying to tell you is that you need to use this point to plug in to the equation that you think is correct to find your a. So basically, I need to find my a. How do I find my a? This is going to make sense after I show this to you. So find a by plugging in additional point. Okay, this is what I mean. So I want a to be a variable. using this point, this is the point I'm going to use. I want to plug this in to solve for a. So if I know my y is 2, and a is a, and then 1 is x, well, what's 1 squared? 1 squared is 1. So this becomes 2 equals 1a. If I divide by 1, it's just 1. So a equals 2. So in this case, my answer is going to be y equals 2x squared. We knew it was a stretch. Sorry, I'm going off the paper. We knew it was a stretch because it looks skinnier than the parent function. So we had to find out what a was. So we find a by plugging in the additional point, and then that's our a. So let's see how it works for the others, and we'll see if we can get it together here. So this vertex is 0, -5, and my additional point I want to locate, I'm doing 1, 2 because those are the steps. My additional point I'm locating is, let's do this one right here. This looks like 2, -1. Okay, so that's that. That's my additional point. So I forgot to write a step here. My step here is to create vertex form with variable a. Create vertex form with variable a. So this is really step 4, and this is really step 3. Okay, so what I think this vertex form is going to be y equals, since I have no vertical or no horizontal movement because my x is 0, I'm going to have, and I'm going to write it just like they did in the first problem so you can see what I'm talking about. Now, do I really need to write -0, or I can just do x squared minus 5? Yes, I'm going to do y equals x squared minus 5. So this is the equation that I think, but do I know if there is an a? I don't know. Guys, y's and x's, x and y's, you can always plug in whatever to see if you get whatever. You have a ton of x's and y's in this graph, so plug in to see if it makes sense, and that's exactly what we're going to do here for step 4. So step 4 is going to be us using this point as y equals -1 equals a times x squared, so that's 2 squared minus 5. Okay, so I'm going to rewrite this as 4a minus 5. Add 5. This looks like 4 equals 4a. A is 1. So we were wrong about this one. This is not stretch, compress, whatever, but we are positive, and we know that a is 1 just to be sure. So this would be our correct equation for number 3. Okay, all of this is basically if it looks like a stretch or a compression. And let's say that maybe you wanted to check it. Let's say I didn't want to go through this nonsense right here, plugging it in. Well, you're really technically plugging it in already. So let's do a real quick check before we do, and we're learning as we go. If we plug in 2, right, 4 minus 5, does that give you -1? Yes. So this one does not have an a. All right, I like that. Let's go here. So step 1 is to find your vertex, which is -4, 0. Step 2, I'm going to find an additional point, and I like this one, -2, 4. All right, so since this has only horizontal movement, no vertical movement, I think that my vertex form is going to be y equals, have to have parentheses because we have horizontal movement, x, and is it going to be plus or minus since my x is negative? It's going to be plus 4 squared. And I would write plus 0 at the end to be extra, but I'm not going to do that because we already talked about that here. You don't need that plus 0. So to check if we have an a, so just listen to me. To check if we have an a, plug in your additional point and see if it works. So I'm going to plug in -2 for x, and see if it equals 4. So this is 2 squared equals 4. Yes, that means that this is our vertex form for number 4. So no horizontal compression, or no compression, no stretch for number 4. Okay, so number 5, step 1 is to find our vertex. Vertex is at 0, 0. And we need to get an additional point. My additional point is going to be 1, negative 2. All right. Vertex form here. There's no horizontal, there's no vertical movement. So if I were to write this the corny way, this would be what I'm talking about in vertex form. However, obviously x minus 0 is just x, and then plus 0 is just the same thing. So my equation is y equals x squared. Now, we have to plug in this point to figure out if we have an a. So is 1 squared equal to negative 2? 1, negative 2. No, it is not. 1 squared is not equal to negative 2. So now we have to solve for a. We have to figure out what a is. So since we know that this is not a equals 1, let's plug in. So negative 2 equals a times 1 squared. This becomes negative 2 equals a, 1a. 1 to divide by 1, divide by 1. So that technically means that our a equals negative 2. So even slight, this is a slight stretch, and it's negative. Well, we know it's negative because it's reflected. So we knew it was going to be a negative. We just didn't know it was going to be a vertical stretch until we plugged this in and realized that that wasn't true. So y is equal to negative 2x squared for here. Okay, number 6. Our vertex is at 1, 1. So slight translations, but we do have. And then our second additional point, I'm going to find at 3, 5. Okay, this is our vertex. This is our additional point. So I'm going to create my vertex form of what I think it is, and we're going to test this point to see if we have an A or we don't need one. I hope I'm making sense. I feel like I'm confusing myself, but I know what I'm doing. I'm confusing myself in terms of, am I explaining it correctly to you? So I hope that you understand this, and if not, I'll go back over it and make sure that we're getting this in a simplified way. So, and I'll write simpler steps. Okay, so y equals, we have movement, so it's going to be x minus 1, since they're both, this is positive, squared plus 1. Okay, we think that this is our equation, so we're going to check it by plugging in our additional point. Okay, if that additional point, when we plug it in, if it works, if we get a true statement, then we do not need an A and this is our answer. However, if it does not work, like over here, then that means we need to go ahead, put an A here, and solve for it. Okay, so plugging in 3, we want to know if this equals 5. Does this equal 5? 3 minus 1 squared plus 1. I can already tell that it does. 3 minus 1 is 2. 2 squared is 4. 4 plus 1 is 5. Yes. So this is our answer for number 6. We did not need an A because this means that 5 is equal to 5. If you want me to write that out, I can. So we want to figure out this problem, if I'm doing it correctly. We want to know, this question mark tells us that we don't know. We don't know if this is true. So we're going to do 5 equals 2 squared plus 1, and it does. So that's how we checked it and made sure that it was correct. Okay, number 7, vertex. Vertex is negative 4, negative 2. All right, and then our additional point, and I'll start saying what I'm actually doing. Additional point is where? Let's see. We can actually do one. It looks like there's one here. Negative 3, negative 1. If I get some crazy answer, then I know that I didn't see correctly. I think that's a good point. There's also one here if we can do it. All right. So we're going to set up our equation to what we think it's going to be. So y equals, don't think that there's an a, so we're just going to go x. Since this x is negative, or my h is negative, I'm going to do plus 4 squared, and the vertical movement is minus 2. Okay, now how do we check if we have an a or not? We're going to plug in our additional point and see if it makes it true. So plugging in, I should have started this up top, but I didn't because I'm clearly capable of spatial recognition. All right. -3. So does this equal -1? So -1, this is my symbol for does it equal. Does this equal -3 plus 4 squared minus 2? I'm coming over here. All right, does -1 equal, -3 plus 4 is 1, so 1 squared minus 2. Does -1 equal, question mark, 1 minus 2? Yes, that is correct. Therefore, this is our answer. There was no stretch or compression, so we don't need to worry about an A. All right, if I'm you, I'm looking at number 8, and I'm saying, well, I know it's going to be reflected, and it pretty much looks like a compression. So let's figure this out together. Vertex of this problem is at 2, 0, and my additional point is going to be here, 4, -2. Okay, so we're going to write what we think our equation is going to be. Y equals, I know it's going to be negative. So if you want to put that negative in, that's fine, but we're going to find out anyway at the end. So let's just make it easier on ourselves and do x minus 2 squared. No vertical movement, so I don't need plus or minus anything over here. And we're going to plug in now. So we're questioning, does -2 equal 4 minus 2 squared? Well, if you're looking at this, you see that -2 does not equal 4. So we need to plug in, or we need to solve for a. So we need to solve for a. So this is not our equation. It's close because I know that this in the middle part is good, but we need an a. We need to figure out what a is. So this is where we solve for a. So y, which is our -2, equals a times 4 minus 2 squared. Now, I'm sure some of you can figure out a way to do this quickly, but I'm just writing it out so everyone can understand where this math is coming from. -2 equals, well, 2 squared is 4, so I'm going to write 4a. If I divide by 4, I get -1/2 equals a. So now we have our a, and now we know our answer is going to be y equals -1/2 times x minus 2 squared. Okay, so this is a good problem. I like this problem. So we had a vertex, we had an additional point. Here's what we think it is. We got to solve for a because clearly it's a compression. We know it's reflected, so we know that this is not going to be it. So now we're solving for a. We have to figure out what that is here. Solve, you got it. Put it together in your vertex form. Okay, let's do 2 more. Vertex is looking like 0, -6. My additional point is going to be 1, -4. Okay, so we already can tell that there's no reflection here. It opens up. So A, if there is one, is not going to be negative. Let's see. So there's no horizontal movement. So I do not need parentheses. So I'm going to have x squared minus 6. So we have an A. Okay, so to check this out, -4 does not equal 1 squared minus 6. That would be -5. So we've got to solve for A. So we're going to do -4. I just want to make sure I got my additional point good. -4 equals a x, not x, a times 1 squared, which is basically just a because 1 squared is 1, minus 6. So let's add 6. We get 2 is equal to a. We've got our a, so our equation is going to be y equals 2x squared minus 6. And the last one, opening up. This probably is another stretch, so we're going to have a factor for a. But let's just find out. Vertex -3, -5. And my additional point is going to be here, -2, -3. Okay, so we have both vertical and horizontal translations. So y is equal to x plus 3 squared minus 5. All right, let's do quick mental math. If we plug in -2, -2 plus 3 is 1. 1 squared is 1. Is 1 minus 5 -3? No, it's -4. So we're going to have to solve for a. So -3, that's our y, equals -2 plus 3 squared, sorry, a, minus 5. So -3 equals a times 1 squared, or just a, once again, because 1 squared is 1. 1 times a is just a, minus 5. So we're going to add 5. 2 equals a. Again, how creative. So our answer, y equals 2 times x plus 3 squared minus 5. Now, if you don't want to see me again, you do not have to come to office hours for the last 2 if you've watched this video and understand what's going on, because the last 2 problems on Math Excel deal with this, deal with some type of thing. So it's not going to give it to you just as is. This is actually harder than what it gives you on Math Excel. So they give you the vertex and they give you the additional point. So all you have to do is start from here and see whether you have an A or not. Okay, so in Math Excel, they give you the points, and you just go from there. So I'm not going to do the graphing because we've already done about 80 minutes of graphing, and I'm kind of sick and tired of it, to be completely honest. So simplified steps for this. Let's talk about simplified steps for doing this. I don't want to say find and locate, so we can just do get vertex. Step 2, get additional point. And again, in Math Excel, they give these to you already. Additional point. Okay, check or create vertex form. Create vertex form equation. Check vertex form equation. So that's basically what we've been doing. So we got our 2 points. We created our vertex form equation. And check using the additional point. Okay, so step 4 is if you get a true statement, you're done. But if not, then you have to solve for A using the additional point. Right? Plugging it in. So step 1, get your vertex. Let's go through a good problem as, oh, of course, it's on the back of this. Okay. I don't care. I like this problem. So step 1 was to get your vertex. Step 2 was to get our additional point. Step 3 is to create vertex form equation and check using your additional point. So we created our vertex form equation and we plugged in our 4, -2 to see if that worked, okay? If true, if you get a true equation, you're done. Well, we didn't, so this part is what we're gonna have to do. If not, solve for A using the additional point. So that's what we did. We had to solve for A, plugging in the additional point. Maybe instead of using, I should do plugging in additional points. So you have to know what vertex form is in order to plug something into that form. So this is y equals a times x minus h squared plus k. That's what we're doing. We're plugging it into vertex form. So we're solving for a, and then when we're done, we get a and put that into your new equation. Okay? So I hope you found this pretty helpful. I enjoyed doing it because I know it was necessary for you. So that's it. Make sure you do your Math Excel. I'm looking through the textbook and I'm like, kind of whatever about it. I know that there was a problem, or there was a few problems. There were a few problems that I had last year just talking about transformations. But if you practice the Kahoot, that'll take care of that. So make sure you go through the Kahoots. Make sure you do your Envision. And tomorrow, which I'm going to record right now, we're going to talk about quadratic roots. So that's going to go back to your packet. All right. Thanks for watching. Have a great day. Bye.